the system asks us to solve it algebraically by substitution. Well, substitution is what most of the students voted for. So we'll do this by substitution. And the easiest variable to isolate is y because it's already isolated. So my plan is, once I've isolated y, I'm going to take this piece and I'm going to put it in here. Why? Because then I can get an equation with only x's in it, and then the y's are not there anymore. So 6x minus 2, 3x minus 7 equals 14. So 6x minus 6x plus 14 is equal to 14. So I can subtract 14 from both sides. Wait a second. 6x minus 6x is 0. 0 equals 0. What is going on here? So if we graph these lines in Desmos, it turns out that we have one line on top of another line. So there are an infinite number of solutions. So we can't give a solution to it because they're an infinite number. And this is true because 0 always equals 0. Now, there's going to be some cases where you try and solve it algebraically, and then you end up with something like 4 equals 2, which is never true. It's not possible for 4 to equal 2. So in this case, there would be no solution. Those lines are parallel. But if you have something that is always true, like 0 equals 0, always true, then you have an infinite number of solutions. So if this happens while you're solving something algebraically, that is why. And please know you can always plug it into Desmos to see what's going on with a weird equation. You can always plug into Desmos in order to check your answer. So write an equivalent system with integer coefficients. A student said that what they would do first is get rid of the brackets by distributing. So I can do that. 1/2 times 2 is just 1x minus 1/2 y plus 3/4 x equals 6. And then the bottom one equation is the same. So far, here's what I've done. So a student said we could multiply the entire thing to try and kill the fractions right away. Or we could gather our like terms with 1x and 3/4 x. So if we want to gather these, then we need a common denominator because we're adding them. So this is 4/4 plus 3/4. So then we're going to have 7/4x minus 1/2 y equals 6. So the suggestion was to multiply this equation by 6 to kill all the fractions. Let's see what happens if I do that. So if I multiply by 6, it has to be every term, right? So then 6/2, 6 times 1 is 6, divided by 2, 3x. And then this simplifies to 2y. And then the 6 and the 3 actually simplify out to 2. So on this side, I have 4. That's the fastest way to write that out. So it was successful because if you carefully choose a multiplier of 6, it will kill off the 2's and the 3's. And now we have an equation with integer coefficients. That means all the coefficients are whole numbers. Let's think about the red one. So the red one probably we can multiply by 4 to try and kill off all the fractions. Students always forget to multiply this one by 4 as well. You're going to do it by 4, it's got to be every term. So those cancel out. So you end up with 7x, and then 4/2 is 2y, and then this doesn't cancel at all, so we end up with 24. So an equivalent system implies that there are 2 equations because there's 2 equations in a system. So your final answer for an equivalent system would be these 2 equations together. Not one of them, a system has 2 equations. And it didn't ask us to solve it, but the reason you would want to do this is so that it's much easier to solve, for example, by elimination. Anne invested $12,000 in 2 bank accounts. One of the accounts pays 6% annual interest, and the other account pays 5% annual interest. If the combined interest earned in both accounts after a year was $700, how much money was invested in each account? Can you write a system that is 2 equations with 2 variables to help you solve this problem? So first we need to set up are variables. How much money was invested in each account? So I'm just going to use my let statement. So let A equal amount invested at 6% interest. Okay, so there's the 6% one. And then the other account is B, the amount invested at 5%. And the reason I've chosen these amounts is because this is what we're trying to find in the end, A and B. So there is an easy equation and then there's a harder equation. We have to put together the clues to figure this out. We know that she invested a total of $12,000. So if we take the amount she invested in A and the amount she invested in B, should come out to $12,000, right? The hard part, and this is kind of like those nickel and dime questions, is figuring out like how much interest she earned. So if you have, let's just go into a little thought bubble here. Okay. If you invest $100 at 5% interest, you know at the end of the year you're going to get $5 in interest. How did you figure that out? Well, you can take 0.05, which is your interest rate, and multiply it by 100. Okay. And if you do that, you're going to get $5. So in general, when you're trying to figure out how much interest you earned, you want to take your interest rate as a decimal and then multiply by how much you invested. So for example, at 6% interest, I can take 0.06. So 0.06 and times the A, because that's the amount invested at 6%. And then, how much did I invest at 5%? Well, we don't know, but it was B. Okay, so 0.05 B. Okay, and then we actually do know what that amount came out to in the end, though, with $700. There's our two equations. I'm not going to go through and solve them right now. If you're interested in how you would solve this, see yesterday's virtual class recording, because you can solve this by elimination, by multiplying the top equation by 0.06, and you can knock out a variable by elimination, or you can do it graphically. But I just wanted to show you how you can set up the equations to do this. So in this example, again, we're investing $12,000. And there's two funds, one at 9% and one at 11%. So we're going to say let A equal the amount invested at 9%, and then B equal the amount invested at 11%. Okay. And so we know that the total amount that we invested is A plus B, and we know we put $12,000 in the bank. So we're going to write that. And then the interest one, you're going to take 0.09 times however much you had in your A account, and then 0.11 times however many you had in your B account. So your interest earned is $11.80. And again, I'm not going to solve that, but you should be able to by elimination. So this one's a little bit different. In 2010, a man saved $5,000. And then the next year, his income increased by 10% and his expenditure decreased by 16%. So I think the first thing you need to think about is that your savings is equal to your income minus your expenditure. Okay. So I'm going to let, I'm actually going to let X equal his income in 2010, and I'm going to let Y equal his expenditure in 2010. Now, this is counterintuitive because what they're asking us is to calculate his income in 2011. But based on the clues that I'm given, I think it would be easier to just let it be in 2010, and you'll see why. Okay? So in the year 2010, he was able to save $5,000. His savings was $5,000. How come? Because he had his income, which was X, and you subtract your expenditure, which was Y. Okay. But then in 2011, his income increased by 10%. and we know how much he was able to save. So we'll put in what we know, where he was able to save $14,600 in 2011. Okay, and up here is 2010. Okay, so we know that his income is not X. It is it's more than X. It's bigger than X. It actually, his income increased by 10%. So what are we saying about this income? Like, what has happened to X? Is it X plus 10? Well, no, because that would mean that he's only making 10 extra bucks that year. Okay. Well, what about using this percentage to say 0.1010% times X? Would that be right? Well, no, that would be 10% of his income. Like if you multiply X by a decimal, it's actually going to get smaller. So we don't want that. So how do we express that he's actually increased his income by 10%? Well, here's a trick. If it's increased by 10%, you want to multiply by 1.10, and that will increase you by 10%. If you don't believe me, come into this thought bubble. Let's say I made $100 this year, and then next year I multiply by 1.10. How much money am I making that year? $110, which is 10% more, right? And that's why that works. So if it increased by 10%, I'm going to multiply 1.10 times X. His expenditure decreased by 16%. This is also quite difficult to come up with because what would I put for Y then? Would I put 0.16 Y? Well, that seems right because it's decreasing, right? But what this would mean is that you have only spent 16% of what you did last year. Now, that would be amazing. If you spend $100 on something last year and you got the same thing this year for $16, that would be incredible. But no, that's still not quite right. Okay? So another way to think about this is that if he saved 16% of his expenditures, then he's only paying 84% of what he used to pay. So here you would put 0.84 times Y. And because of this 0 point, we know we are going to shrink that expenditure amount. Okay? And it's actually 84% of what it used to be. So this is a trick that's going to be coming up continuously, Math 20, Math 30 as well, knowing how to use percentages to set these up. And understanding that if you stick a 1 in front of it, it will grow by that percentage. And if you are decreasing by a percent, you have to take the subtraction and figure out what percent was actually left. So there's equation 1. There's equation 2. We have 2 variables, so we could solve it. I'm not going to solve it right now. We did questions like this yesterday, and you can take a look at that video that's posted in the blue column virtual class, extra examples.